Good morning, welcome to a new session of video class. In this class, I will discuss about various methods of production of hydrogen. Various methods of production of hydrogen. This particular topic is one of the most important topic in the syllabus of renewable energy paper of final year BSc 6th semester. Already we began previously in our classes about the significance of hydrogen as a fuel and the history of hydrogen as a fuel. Now, in this topic, in this particular session, we are going to discuss what are the various common methods that are employed in order to produce the hydrogen, across this globe, Right. Before going to the topic, let us have a small discussion about or small words about the hydrogen fuel. We know that hydrogen it was recognized as the future energy source. The future energy source means hydrogen is the significant energy source which address the needs of the present energy consumption as well as the requirements of the energy for the future generations also. This is one of the renewable energy source. Along with nuclear energy, hydrogen energy, these two energies are considered as the most versatile and powerful energy sources that will certainly address the requirements of or fulfill the requirements of the energy as far as the coming generations or future generations are concerned. Particularly the hydrogen, the nature of the hydrogen is very excellent. It is an eco-friendly, it is zero emission fuel, it is a zero emission fuel, it is non-pollutant fuel, it is abundantly available. Okay. There are so many such great properties are there due to which hydrogen was recognized as the future energy source, And one more thing, hydrogen is not a primary energy source. Primary energy sources like solar, as far as the renewable energy sources are concerned, the primary energy sources are solar energy, wind energy, ocean energy. These energies are primary energy sources. Similarly, the non-conventional energy sources like coal, oil, and natural gas, they are also primary energy sources, which are available in the nature and directly they can produce or they are used to produce the different types of energies. Whereas hydrogen is not directly generates available in the nature. First of all, it should be produced from various other sources. As it is supposed to be produced from the other sources, so it is known as the secondary energy source or energy carrier. Whatever it might be, it is a potential energy carrier like electricity. It is a very powerful energy carrier. It is very versatile energy carrier. It can certainly address the environmental needs also. It can decarbonize all the present energy resources are concerned. All the sectors are concerned. It is ultimate to the all the conventional energy sources. It is ultimate energy to the all the conventional energy sources. These are all so many properties, so many positives that are there as far as the hydrogen energy is concerned. Therefore, it is known as the future energy source. Right. Now, how to produce this hydrogen, because it is not directly available in the nature. it is available in the form of other compounds with the other elements. Therefore, it has to be produced. It has to be produced. Okay, that's why we will see what are the various methods of production with which a hydrogen can be produced. Okay, right. For that one, I will directly upload the student material and I will discuss various methods with which a hydrogen can be generated or hydrogen can be produced. Right? This one, hydrogen production methods. Right. Okay. Hydrogen is the third most abundant element of the earth. Okay, hydrogen is the third most abundant element, okay, on the earth is concerned. But it does not exist in free state. It means that it is not directly available. Large amounts of hydrogen is available in compounds such as water, fossil fuels and biomass. Huge amount of hydrogen is available, okay, in the compounds such as water, fossil fuels and biomass along with the other elements. Okay, right. That's why these are the three major sources in which hydrogen is abundantly available. World's annual production of hydrogen gas from all sources is nearly 500 billion cubic meter. Okay, as far as an estimation is concerned, by means of an estimation, it was proposed that or it was said that from all sources of hydrogen, okay, there is about 500 billion cubic meter of hydrogen can be produced per annum. This is the annual production of the hydrogen. This amount weighs, okay, 50 million tons. Okay, this will be weighs 50 million tons of the hydrogen with an energy content of which contains 6 in 10 to the power of 18 joules. Large part of hydrogen is produced from steam reformation. What is the process with which we will able to produce the large amount of hydrogen, that is what is known as the steam reformation of natural gas and some from fossil fuels also. There are about 6 methods with which hydrogen can be produced. Fundamentally, there are 6 methods because now the technology is increasing, so many other methods are there, but fundamentally there are 6 methods with which we can able to produce the hydrogen. The first one is the steam reformation. In this process, steam, okay, it means that water vapor will be combined with iron. In this method, steam is passed over a hot sponge iron sheet. Okay, and steam will be passed over hot sponge iron sheet, which is at a temperature, okay, 550 degrees centigrade to 800 degrees centigrade. In this process, the hot iron and steam react to produce ferric oxide and hydrogen. In this process, what will happen? The hot iron and steam will react to produce ferric oxide and hydrogen. Of course, CO and carbon dioxide, that is the other step will be there. Okay. Therefore, in the first step itself, 3H2O plus 2Fe gives rise to Fe2O3 plus 3H2O. This is the chemical reaction with which we can get the three molecules of hydrogen, okay, 3 molecules of hydrogen due to the combination of steam, okay, and iron at a temperature of 500 degrees to 550 degrees centigrade to 800 degrees centigrade. Next one, this is what is known as the steam reformation. Reformation means to conversion, change of state of the steam. That is this one, right? Next one is thermochemical method. Thermochemical method. The name itself indicates that there is a chemical process at the presence of heat. At the presence of heat, by means of some chemical process, we can able to produce the what is this one, hydrogen abundantly. This is the most efficient, commercial and cheap technology used widely. At present, what is this one? This is the most efficient technology. This is most commercially used technology and this is most cheap technology with which we can now produce more amount of hydrogen. Okay. One estimation says that or one assessment says that 95% of the hydrogen produced in USA is in this process, or this is the process that is employed by the production of hydrogen, sorry, by the USA to the production of hydrogen, okay, as far as their hydrogen reserves are concerned, and their hydrogen reserves are 95% of the hydrogen reserves are generated by means of this process. Okay, this is a thermochemical method, okay, in which a reaction takes place between primary energy source and water. Okay, between primary energy, that is the heat energy, water and specific chemical to produce hydrogen at temperatures more than 700 degrees centigrade. This temperature generally takes place between the after 700 degrees centigrade. Okay, at this temperature, some specific chemical and water will combine together to give the hydrogen. Let Z represents a metallic ion or complex radical ion. Let Z is a metallic ion. ZOX plus H2O gives rise to ZOX plus 1 plus H2O. It means that okay, ZOX plus O, water gives rise to ZOX plus 1 plus O, hydrogen is generated. Now this is ZOX1 plus heat, it combines with heat and it again produces ZOX plus half O2. Okay, if you observe this one, what will happen? If a complex metallic ion oxide is combined with hydrogen, you will get the, sorry, water, you will get the hydrogen. But as a product, you are getting ZOX plus 1. The ZOX plus 1 again divides into ZOX plus oxygen. It means that in this particular reaction, you will get hydrogen and oxygen. Of course, oxygen amount is double than the hydrogen, sorry, hydrogen amount is double than the oxygen amount. And once again, in this particular reaction, okay, as a product, the final product is the initial ingredient. It means that okay, initial ingredient is the ZOX. Okay, this was also available from the final product. That is also one of the advantage. And in this particular method, you are getting oxygen, also hydrogen. Of course, the hydrogen is double to the amount of oxygen. Okay, but oxygen is the life gas. You know that all these things. That's why that is the added advantage as far as this method is concerned. This method is known as the thermochemical method. Right. Electrolysis of water. Water H2O. It consists of oxygen, nitrogen. Electrolysis means division of water into all its constituents. So by passing electrical current is known as the electrolysis. Okay, that's why electrolysis of water, okay, is the decomposition of water into its ingredients, that is the oxygen, nitrogen gas. This takes place due to direct electrical current passing through the water using two electrodes. Okay, the reaction ideally requires a potential difference of 1.23 volts per hour to split the water. Okay, what is the amount of potential that is actually required to divide the hydrogen and oxygen from water, that is 1.23 volts. Okay, this technique can be used to make hydrogen fuel, hydrogen gas, and breathable oxygen. In this one also you are getting the breathable oxygen. That's why this is also one of the very interesting methods. Okay, the cathode and the anode reactions are as follows. At cathode, reduction takes place. What is meant by reduction? One of the meaning of the reduction is addition with addition of electrons are known as the reduction. Therefore, in the reduction, okay, liquid H2O, liquid water combines with two electrons to give hydrogen gas and OH aqueous. Okay, aqueous, OH aqueous. And at the anode, oxidation will take place. Oxidation means liberation of electrons. Okay, therefore this the generated OH minus in the aqueous position, okay, it will give O2 plus 2H2O plus 2 electrons, 2H2O plus 2 electrons. It means that you are getting oxygen and again you are getting water, and of course the electrons are also generated. Therefore the overall reaction is 2H2O liquid. It means that the liquid water gives rise to 2H2O, hydrogen plus O2. In this reaction also, the hydrogen, the product of the hydrogen is double to the oxygen. It means that you are getting hydrogen and oxygen by the electrolysis of hydrogen water, no doubt. But the amount of hydrogen that will be generated will double to the amount of the oxygen as far as the electrolysis is concerned. This is a very interesting thing. Electrolyte solution like KOH will be added to, since the water is not a pure water is not a good conductor. In order to make the Electrolysis, by passing electrical current, we need to, okay, some energy current carrying agent, therefore we will use KOH as the current carrying agent because pure water is not a conductor. Okay, right. The energy required to produce hydrogen is 3.5 kilowatt hour per cubic meter. Okay, okay. The energy required to produce hydrogen in order to perform the electrolysis of water of each cubic meter of water, it needs 3.5 kilowatt hours of energy required to perform the what is this one the electrolysis. Okay, therefore in this electrolysis we are also getting oxygen and hydrogen, but the hydrogen is double with the amount of oxygen. Next one, coal gasification. Coal gasification means conversion of coal into steam or gas. It means that this will be conducted at a high temperature. At this high temperature, coal will be totally in this method, organic part of the coal is completely converted into gas, and only the ash will remain. This is done with the steam at 700 degrees centigrade and coal. Okay, this particular reaction will take place between coal and steam at 700 degrees centigrade. In this process, carbon in the coal reacts with the steam to produce carbon monoxide and H2O. By the original reaction, in this original reaction, at this particular temperature, carbon in the core will react with carbon in the core will react with carbon with the coal with react with what this one react with steam, and it will produce carbon monoxide and hydrogen. Okay, the carbon monoxide then converted into carbon dioxide in the other formula, and additionally it will give hydrogen. It means that this particular process is having two steps. In both the steps also you are getting hydrogen. Okay, let us see this one. Okay, carbon plus H2O, carbon plus water is equal to steam in the form of steam is equal to CO plus H2O. Now carbon monoxide plus other water H2O plus H2 gives rise to CO2 plus 2H2O. In this way, we will get to more amount of hydrogen as far as this particular method. This is what is known as the coal gasification. Coal gasification, right? Methane reformation. Methane reformation. Methane mixed with steam is passed over a nickel oxide catalyst at high temperature. In this particular topic, in this particular method, methane mixed with water is passed over a nickel oxide catalyst at high temperature. Reformation reaction takes place, and it is an endothermic reaction. Endothermic reaction means energy will be generated. Okay, reformation means formation will change. That's why CH4 plus H2O gives rise to CO plus 3H2O, and heat will be generated. The product CO again combines with what will happen steam. It means that hydrogen, water, and of course it will. We know that it will produce carbon dioxide and hydrogen. Okay, right. That's why methane gas reformation is also one of the very interesting methods in which we will get to hydrogen along and also the carbon dioxide. Next one, solar metals. There are certain natural metals that are the solar metals. So that is biophotolysis. Biophotolysis. In this method, hydrogen is produced with the help of photosynthesis microorganisms. Photosynthetic microorganisms are used to produce hydrogen in the biological method. Blue green algae. What is that one? A blue green algae and anaerobic bacteria and blue green algae are capable of splitting up of water into hydrogen and oxygen. Okay, consuming light. What this one? Blue and green algae and anaerobic bacteria, they will consume light, and by consuming light, these bacteria capable of splitting up of water into hydrogen and oxygen. Okay, hydrogen and oxygen. This is okay. Bioelectrolysis. This is nothing but the bioelectrolysis. Okay, right. In this one, the bacteria can able to split the hydrogen and oxygen in the water. This is called the photolysis. This is also known as the photolysis, biolysis or photolysis. Okay, ingredients are biological material, therefore biolysis. Okay, as they use photo energy, it is also known as the photolysis. Next, photoelectrolysis. Photoelectrolysis means it is electrolysis. It is electrolysis means by passing the electrical current through water, you will get the okay. You can able to divide water into hydrogen and oxygen, and this electrolysis can be done by means of the photo energy. It means that the light energy. It means that we have the photoelectrolysis material. Electrolysis setup. It means that a beaker, water. It is likely combined with KOH. Two electrodes are immersed. Now, instead of connecting this electrodes to a battery, it is connected to the what is this one? Photocell. Photocell. There it is connected to the photocell. Okay. Okay. Then what will happen? The photocell, which current generates electrical current, will pass through the circuit and it will perform the electrolysis. Right. In this process, so decomposition of water into hydrogen and oxygen takes place with the help of the yes, electrical current only. In this method, the electrical current is generated when the two electrodes are exposed to sunlight. The two electrodes are exposed to the sunlight. For this, one of the electrodes should be semiconductor, and the other electrode, okay, the catalyst is also included to activate the electrodes. Okay, one of the electrodes should be semiconductor. Then once the electrodes are exposed to the what is sunlight, okay, some potential difference is arise. This because of the potential difference, electrical current flows between anode and cathode. Okay, therefore the water will be decomposed into what is this one? Its constituents, that is the hydrogen and oxygen. That's why this is what is known as the photoelectrolysis, and this is photolysis. This is due to what is one? The bacteria. And of course, this is nothing but the electrolysis, in which in the place of the electrical cell, we will use what is one? Photo energy from the sun. Right. Recently, hydrogen production method is developed only from sunflower oils also. Okay. This is sunflower is a biofuel. By means of this biofuel, also we can able to produce the hydrogen. And as far as the research present, as far as the current researches are okay revealing this one. Therefore, this is one of the methods with which we can able to produce the hydrogen. That's why these are all the different methods with which these are all the different simple methods with which we can able to one amount of hydrogen, okay, from various methods, because hydrogen is appears to be the future energy source. Okay, the future energy source. Right. Okay. Right. This is about all this is about different methods of production of hydrogen. See you in the next class.